5-6 dilations. I can identify and create dilations.
All right, so what is a dilation in your own words? A dilation in your own words would be what, Ryan?
It's a change that.
It's a change, right? Are we changing the shape or changing the size of a shape? Size. We're not changing the shape. If we're changing the shape, we're not really dilating it, right? So a dilation is a transformation, as you're going to say. It's a change in which we change the size of the shape, but not the actual shape itself. Okay? Transformation is a change. An image. Look in the mirror. You see an image. It's the copy, right? An image is going to be your copy. And then we mark images with what kind of markers? What do we use to mark images so that we're clear, Sukalan?
Prime markers.
Prime markers. And these are prime markers. So because quadrilateral ABC is compared to quadrilateral A prime, B prime, C prime, D prime, we know that the image, the copy, would be the one with the prime markers. Okay, and number 5, center of dilation. Very important word. Very important procedure. It is the challenge that came with this lesson. All right, so center of dilation. Basically what we said here, I'm going to go over to the cheat sheet idea. To find center of dilation, connect corresponding vertices. This is corresponding vertices and extend to a single point. So I have point A, I have point A prime, I have point B, I have point B prime, I have point C, and I have point C prime. Connect the dots, connect the corresponding vertices, extend it out, you will find your center of dilation. 6 is an example of that, 7 is an example of that, and 8 is also an example of that. I'm sorry, did we skip a number, you guys? 7, okay. So 7, 8, and 9. Notice that number 9, the center of dilation, is actually one of the vertices. So that is possible. The center of dilation is actually one of the vertices. So it was point A. Okay, dilating with scale factor, question. If you are dilating with scale factor and you're using the origin as the center of dilation, what's the process? So the origin is the center of dilation. What's the process? Amelia? Multiply by the scale factor. If you're multiplying by a number greater than 1, what's going to happen to the dilation? It's going to get bigger. If you're multiplying by a number less than 1, it's going to shrink. Okay? So again, if the dilation is the origin, so in this case, we didn't give you, if the center of dilation is the origin, you simply multiply by the scale factor. In this situation, we did not give you a center of dilation, so what do you automatically assume? It's the origin. Now, the challenge came on this guy. We gave you the center of dilation as point P. A, B, C, D, the quadrilateral in red was the given. Your job, using a scale factor of 1/3, was to draw the image with P as the center of dilation. Again, we talked about using side lengths. So if side length AD was 6, what must AD prime be? 2, because we have a scale factor of 1/3. We talked about going from point D to point C. We had a rise of 9 and a run of 6. So to go from D prime to C prime, the rise must be
1.
So if you have a rise of, 6, from D to C, we had a rise of 9 and a run of 6. So you just use a scale factor of 1/3, right?
Yes.
9 6 would be 3/2, right? So from D to C would be a rise of 9 and a run of 6. From D prime to C prime would be a rise of 3 and a run of 2 because of the scale factor that's involved. So using all of those bits of information, you should be able to come up with the image and get it plotted in the point so that P is the center of dilation once you connect corresponding vertices. Lots of crazy keywords here that you need to understand. This one's going to require some practice. We did not do a cheat sheet idea for our last couple of problems, 10 and 11. You might want to do that after we're done with the video here so that your notes are complete.